All right, class, welcome back. Can everybody hear me okay?
Yes, sir.
All right, rock and roll. So last time we did a lot of factoring and we used the quadratic formula to do so. I'm going to redo most of the last lecture because there is a trick that I did not know about that allows this to be a whole lot easier. All right. So again, we could use the quadratic formula to factor it like last time. But for problems like this, where you have a number in front of your x squared and you can't just simply look at it and eyeball it and write down your factors, the goal here is to rewrite this middle term as the sum of two other terms. For instance, this plus x could be written as plus 3x minus 2x, right? And that would be equal to x. And we try to group these two terms and these two terms, right? So if I did this, right, I could look at this and these two terms I could factor out like a 3x and I get a 2x plus 1. And over here I could factor out like minus 2 and I get an x plus 1, which didn't quite work out. What we're aiming for is to have the same two terms so that these two factors look the same. So the 3x and the 2x here didn't work, but there's like an infinite number of possibilities. So in order to figure out the right one, what we do is we look at our a and our c here, and we look at their product. A times c here is a negative 12. What we need is two numbers. I'm going to call them p and q, so that if you multiply them, you get the same thing as a times c. Then we look at b here. B here is 1. The other part we need is we need p plus q to be equal to 1. So p times q has to equal a times c, and p plus q have to equal b. All right. These are the two things that we need, our two numbers to do. So here AC is negative 12 and B is 1. So can we think of two numbers that multiply to give us negative 12 but add to give us 1? Maybe uh, 4 and negative 3, right? They multiply to be negative 12 and they add to be 1. So what we do now is we take this middle term, this x, and we're going to write it as plus 4x minus 3x. Let's see, that might work. No, we got to do it the other way. Do minus 3x plus 4x. Because that way we can factor the 3's out of here and the 2's out of there. So when we do this, we factor out our 3x. We have a 2x minus 1. And over here, when we factor out 2, we get a 2x minus 1 again. So now that we have those same two factors, we have a 3x and a 2, and they're both being multiplied by a 2x minus 1. So that's our factorization. So here's our trick. We need two numbers that multiply, they give us the same as when you multiply a times c. And those two numbers have to add to give us the middle term. And then you can do this factorization in 3 lines. Y'all remember last time using the quadratic formula was kind of brutal, right? But the quadratic formula will work for any of these, even if you had something ugly like 0.01 x squared minus 32.7x plus 9, Quadratic formula will work for everything. But for these types of simple problems, we can do this trick. So let's check out another example here. So let's see, our A and our C here is 5 times 8, right, which is 40. So we need our P times Q to be a 40. Our B here is negative 14. So we need our P plus Q to be a negative 14. So two numbers that multiply to give us 40, but add to give us a negative 14. Maybe a negative 10 and a negative 4. They multiply to give us a positive 40, and they add to give us a negative 14. So again, what we do is we take this middle term and we rewrite it using these two numbers, a negative 10x and a minus 4x. And I wrote it in this order because these are both divisible by 5, these are both divisible by 4, right? If I had to put the 4x first and the 10x second, it wouldn't have worked out because the 4 and the 5 don't have anything that divides them both. So again, we just rewrote this middle term like that. And we figured out these two numbers by using this little trick. So now I can factor out a 5x from these first two terms, and I get an x minus 2. Now these other two terms here, if I factor out 4, actually let's factor out a negative 4. If I factor out a negative 4, I have an x and a minus 2, right? Negative 4 times a negative 2 is a positive 8. That way we have the same two terms. We got a 5x and a minus 4, and they're both being multiplied by an x minus 2. So what do y'all think? Is that a lot easier than what we did last time?
Yeah, a lot easier. Just gotta get familiar with it or used to it.
Yeah, it took me a little while to get, the trick down. Sometimes it's hard to find your P and the Q. You can use whatever letters you want, to represent these numbers, but let's just look at more examples here. I guess I learned this when I took college algebra, which was a long, long time ago, and I never used it since. So I always just use the quadratic formula, or the problems were such that I could just eyeball it and factor them, So here our A times our C. Our A is 9, our C is negative 10, so A times C is negative 90. So we want our P times our Q to also be a negative 90. See, our B here is a positive 9. So we need P plus Q to be a positive 9. So we start thinking about numbers that we can multiply to give us negative 90 that add to be 9. I don't know. Let's see, 90 is divisible by 5, right? 18 times 5 is 90. So let's see. We can't use this. If I tried like a 5, then this would have to be an 18, but they don't add to be 9, so it can't be that. See, 9 and 10, right? But they would give me a 9. Let's see, what else can we try here? 90. Let's see. Numbers that add to, one has to be positive, one has to be negative. Let's see. 30 and 3, no. 4, no. There it is. I just tried different numbers. I divided 90 by 2, and then 3, and then by 4, and by 5, and figured out what the other number was, right? But I got to 6. 90.
6 and 15.
Yeah, exactly. And we got to have our negative.
-6.
Yeah, so they multiply to give us -90, but they add to give us 9. So we're going to rewrite this guy over here, this 9x, as a 15x minus 6x. So let's see, I'm not sure which one to put first. So if I did a minus 6x and a 15x, these are both divisible by 3. These are both divisible by 5. Let's see if that works. We might have to switch these. So if I pull out a 3x out of these first two, I get a 3x minus 2. Now if I pull a 5 out of the second two, I get a 3x minus 2. All right, it worked out. So we got a 3x and a 5, and they're both being multiplied by 3x minus 2. I'm used to textbooks where, you know, whenever any of the little vocabulary words I haven't heard of or whatever, or little tricks that I, have long forgotten, they're in the textbook, but we're working out of this packet. And so I got to, recall all these things. This is the first time I've taught this particular course. So there's always a challenge, Let's see, here our A times our C is 9 times 7. What is that, 63?
Yes.
All right, negative 63. So we need our P times a Q to be negative 63. Our B here is 16. So we need P plus Q to be 16. And turns out
21 and -3? No, right?
I'm thinking it's the two numbers we just used to get 63. The 9 and the 7, right?
But one of them would have to be negative to get -63.
Yeah, that's right. So 9 and 7 won't work. Okay. Well, let's see.
Would
Yeah,
it be 21 and -3? Or would
well,
that be 17?
yeah, 21 minus 3 would be 18, right?
Yeah.
So let's try 21 and see if 63 divided by 6. No. 3 divided by 7. No. Get rid of that one. 8. 11, 12, 13. About 13. No. I don't know if this one is factorable. All right, I'm going through all the possibilities. I don't think this one is factorable. Yeah, I don't think you can use this trick on this one because I'm taking 63 and dividing it by 3. Yeah, the 3 and the 21 just don't, they give us 18. I think this might have been a typo. They might have meant to have an 18x here. So let's change the problem. So again, you can see that this trick doesn't work for all the problems, right? They only work for certain ones that come out just right. That's why I didn't remember this trick, So let's just change the problem because I figure this is probably a typo. Let's say that is an 18 there. Then our P here would be what, 21, and our Q would be a -3. So those multiply to give us -63, and they add to give us an 18. So if we rewrite this 18x as 21x and minus 3x, here we can pull out a 7x, so we get an x plus 3. And over here, let's pull out a negative 3, so we can get an x plus 3 here again. Negative 3x minus 9. So we have a 7x and a negative 3, both being multiplied by an x plus 3. All right, any questions? This trick's getting a little more clear, right? More examples you work, the easier it becomes. All right, our A and our C. 8 times 9 is, what is that, 72? Can't remember my elementary school math.
Yeah, 72.
All right, cool. Oh, and that's negative, right? Negative 72. So we need our P times Q to be negative 72. Our B here is 6. So we need our P plus Q to be 6. So let's see here. 72.
Negative 12 and 6.
Yes, exactly. Or a positive 12 and a negative 6, right? Because they have to add to give us the positive 6.
Yeah.
So if we rewrite 6x using these two numbers, let's see. I'm not sure which one to put first. Both numbers share a 2 with an 8, right? You can pull a 2 out of both of those. But looking at the 9 here, well, they're both divisible by 3. Let's just put them in any order and see what happens. So if we pull out a 4x here, we got a 2x plus 3. So we want to get a 2x plus 3 again here. So if we pull out a negative 3, we got a 2x plus 3 again. All right, so we have our 4x and our minus 3, both multiplied by 2x plus 3. All right, our A times our C is 70. And so our P times Q has to be 70. B is 19. So P plus Q has to be 19. So let's see. 70. Two numbers multiplied to give us 70. What is 70 divided by 5? 14 and 5 are at work. All right. So we try 14 and 5, both positive. They add to give us 19. They multiply to give us 70. So let's rewrite 19x as, see, if I do 14x plus 5x plus 7, that won't work because I can't factor anything out of here, right? So I obviously need to rearrange this. I need to do 5x plus 14x the other way around. That way I can factor a 7 out of here and a 5 out of there. So I pull 5x out, I get a 2x plus 1. And then for these two terms, if I pull a 7 out, I get a 2x plus 1 again. So I got a 5x and a 7, both being multiplied by 2x plus 1. All right, we're 20 minutes in, so let's have a quiz. See, this is what, number 17? What is today? Tuesday? Yeah, this would be quiz 17. So See, we're on page 139. I don't want to forget that.
Will this be due at midnight or no?
Yeah,
Okay, because I'm driving right now.
yeah, that's fine. Yeah, you can get the quiz out of the class notes.
All right.
Well, 139. Let's do some of these square root methods on page 135. I think I've given y'all a couple of these problems before. Not sure which ones, but let's see. Y'all remember which ones of these I gave y'all last time? Let's try this one. And yeah, we'll do 4 and 5 here. So don't forget about your square root of -1, all right? You can't just throw those away. If you got a square root of -1 in there, you're going to end up with I in your solution. So let's take 15 to do these. So that'd be 3. Let's see, it's 322. So 32, 337. We'll review these. Make sure y'all help one another out. Work the problem and compare your answers with one another. Go. Resume my recording. So using the square root method, for this thing here, we just want to get our x squared by itself. So we'd subtract 20 from both sides, divide both sides by 5. So that gives us what, a -4. So if x squared is equal to a -4, take the square root of both sides. Square root of x squared is the absolute value of x. This minus here is the square root of -1, and the square root of 4 is 2. So that tells us x is positive -2i. So don't forget about that I there. You can't just throw that -1 away, right? So let's look at this one. Same trick. Subtract 81 from both sides. Divide both sides by 4. Square root both sides. All right, the square root of x squared is the absolute value of x. This minus inside the square root is going to give us an I. The square root of 81 is 9. Square root of 4 is 2. So x is positive -9/2 I. All right, I gave these problems to my other class for an exam. At least half of them would just throw the I away. You can't just throw that minus sign. You have the square root of -1 here, which is rewritten as I for convenience. Any questions about this? All right, let's move on. And I forget what page we were on. 139. Yeah, and we just did 26. So we're on number 27. All right, so we're going to use our A times C trick. It'll be a -6, so we need a P and a Q that multiply to give us a -6. B is -5, so we need our P and Q to add to give us -5. So it shouldn't be too hard. We got what, 6 and 1, -6 and a +1. So we take this -5 and rewrite it as a -6x plus 1x. Now we can factor out a 3x here. We get an x minus 2. So at this point, what do we do here? We want to be able to factor, right? Notice we have our x minus 2 and we have our x minus 2, right? But if we're going to factor this, we need a 3x plus something times x minus 2. So what are we multiplying x minus 2 here by? We're multiplying it by 1. We just don't bother writing that. So we'd have to factor this as 3x plus 1. So we have a 3x times an x minus 2, and then a 1 times x minus 2. It gives us our x minus 2. Does that make sense to y'all? Make sense to anybody?
Yeah, I'm still getting used to it, but I understand it for the most part.
Yeah, there's a hidden 1 there. We don't bother writing it, but to make it explicit, right? We have a 3x and a 1 that are both being multiplied by an x minus 2. It's just up here we don't bother writing that 1, you know. Let's look at 28 here. So our A times our C, 12 times 6, we got -72. So we need P times Q to be -72. V is 1, we have 1x. So P plus Q needs to add to be 1. So let's see, what do we got? 9 and 8, right? If P is 9 and Q is -8, those multiply to give us a -72, right? And they add to give us a 1. So we can rewrite this guy, this x, as 9x minus 8x. So these first two terms, we can pull out a 3x. So we get a 4x plus 3. Right? There's our 9x. Then over here, we can pull out a -2. And that leaves us with a 4x plus 3. So we got a 3x and a -2, both being multiplied by 4x plus 3. All right, I don't remember if we made it this far last time. Did we make it to factoring these? I don't want to redo these if we did them last time. Does anybody remember? I can look at the class notes real quick. So it's this time. It was last time. No, That's where we ended, was on that 28. Okay, cool. So these types of problems look a lot like the other ones, right? If you notice, this is the difference of two squares, right? This is x squared minus 7 squared. Most of these problems are going to be like that. What you need to know here is if you have something squared minus something squared, the factors like this: a plus b times a minus b. See, there is no ab term in the middle, right? Over here, there is no x. There's just the x squared and the number. So you get the a squared, you got the negative b squared, but the ab and the negative ab cancel one another out. So problems like this is a difference of two squares. It's going to factor to be just like that. You always look out for the difference of two squares. So you got your x squared, your negative 49, the plus 7x and the negative 7x go away. So this one here, this is a 2x squared minus 9 squared. So this would be a 2x plus 9 times a 2x minus 9, right? That gives us our 4x squared. That gives us our negative 81. We got a negative 18x and a positive 18x that cancel one another out.
So that's all you have to do for those?
Yeah,
Oh, that's okay. That's easy.
differences. Look for differences of two squares. Okay. Now here's something a little bit deeper here. These are both squares, right? 9 is 3 squared, isn't it? But this is a plus. It's not a negative, isn't it? Remember that
So would it be x plus 3 and then another x plus 3?
well, if we did x plus 3 times an x plus 3, what would we get?
X squared and 9?
We get our 9 here, 3 times 3, but we'd get a 3x and a 3x,
Oh, yeah.
right?
Mm-hmm.
So it doesn't work out. But if you remember I, right?
Yes. Would that
I,
take the place of it?
the square root of minus 1, right? Well, if you square it, you get a minus 1, right? That's the trick here. This is minus 3i squared. See, 3 squared gives you your 9, right? That I squared gives you a minus 1, which cancels
Which
that
would
minus
be
1.
2x. Okay, I get it now.
Yeah, so you got an x plus 3i times an x minus 3i. All right. So even if it's a plus there, that just means you're going to have an I involved. And yeah, we've used 49, 81, and 9, right? And those obviously have easy square roots, right? But it doesn't matter what that number is. We can take the square root of anything, all right? Which we should see here shortly. Here, let's do a quick example. What if I have an x squared minus 47, right?
So
You're
it'll
like, well,
be
that's not something squared, right?
7i.
Yeah, this is the square root of 47 squared, isn't it? So you would factor this as x plus the square root of 47 times x minus the square root of 47. So it doesn't have to be just some simple, you know, a number that we can obviously take the square root of. The square root of 47 is the square root of 47, right? So this works for, you know, any problem like that. Doesn't just have to be the pretty numbers. So let's try this one. This one here, we got x's in both of these terms. So, oh, and we also have a 2. What if we pull out a 2x first? This would give us a 16x squared minus 1, right? There's our 2x. That gives us 32x cubed. This guy, right, is the difference of two squares. 16x squared is a 4x squared, and 1 is 1 squared. So this would be a 4x plus 1 times a 4x minus 1. There's our 4x squared, our minus 1. The negative 4x and positive 4x cancel one another out. So this guy has 3 terms because it has a third power. This one, let's pull a 25 out just to see what we can do here. If we do that, now we're looking at this. Now if we focus on this one term, again, it's a plus, right? But we can rewrite it as a minus by using the I. Remember, the I squared is a minus 1 times a minus gives us a plus. So we got our 25 out here. We got an x minus 2i times an x plus 2i. All right? 2 times 2 is 4. I times I is a minus 1. And then the minus gives us our plus. All right? When you do problems like this, you can always check your work by multiplying it back out, making sure you get your original answer. So always check your work. (49 minus x squared). This is 7 squared minus x squared. This is 7 minus x times a 7 plus x. Doesn't matter which way you put, where you put the minus, you know, if the x comes first or not, it doesn't matter. All right, we got a bunch of x's here. We could pull an x out first. We got an x squared minus 1. All right, that gives us our x cubed and our minus x. 1 is 1 squared, isn't it? So we have our x out here, and then we have an x minus 1 times an x plus 1. There's our minus 1, our x squared, minus x plus x. So the middle terms go away. (36). We can pull a 3x out for starters. That would give us x squared here and a 4. So 4 is 2 squared. So our difference of 2 squares, we get x minus 2 times an x plus 2. And there's our factorization. Any questions? All right. All right, here's a function, f of x. Here's its graph, right? Here's its x-intercepts. Remember how you find the x-intercepts? You take your function, set it equal to 0, and solve for x. Remember that? All right, we make the y value 0, because each of these points here, the y value is 0. Negative, right? So we set our y value, or f of x, equal to 0, and we'd solve for x. All right, so it turns out that if you treat this equation like a function and graph it, if you look at the x-intercepts, it tells you what the factors are. All right, I graph this guy, there it is. I look at the x-intercepts, here's our function. the factors are going to be x minus the intercepts. So we'd have an x minus a -5 and an x minus 2. We know those are the factors because that's when the function is 0, right? If I plug a 2 in, I get 2 minus 2 is 0, right? So if you're having problems factoring something, you can always just graph it and look at the x-intercepts, right? The way they say it here is x equals -5 and x equals 2 are the x-intercepts, right? So if you subtract 5 from both, or add 5 to both sides, you got x plus 5 equals 0. Notice that the two minuses make a plus, x plus 5. So when x plus 5 is 0, the function is 0, right? Or over here, the 2, right? You got x minus 2. Whenever this is 0, the whole function's 0. If this is 0, the whole function's 0, right? So when you factor it, you can easily see the x-intercepts. But if you know the x-intercepts, you can easily write down the factors. So let's look at another example. So this is x squared minus 4x. All right, here's our x-intercepts at 0, 0, and at 4, 0. So I know that this function can be written as x minus 0 and x minus 4, right? That is the factorization. Think about it. X minus 0 is just x, right? I multiply this in, x times x is x squared minus 4x. Same thing, right? So just by knowing these 2 points, I can write down the factored form of the function and tell you what the whole function is. Just by knowing those 2 points, I know what the whole function is. It's crazy, right? Let's look at another example. So we're going the other way this time. Sketch a possible graph for this function. I could tell you the x-intercepts are at 5 and at -2, right? So at 1, 2, 3, 4, 5, that's a point on the graph, and that's a point on the graph. Now this thing could look like this, or it could look like this. But we know the a, if we multiplied that out, you got x squared. Yeah, we got a minus 5x and a plus 2x and a minus 10. But a here is 1, which is bigger than 0, which means this thing opens up. So we know that's what our function looks like, the graph of our function. So from the factors, we know roughly what the graph looks like. I mean, it could look like this, or it could look like this, but it's one of those. It falls into that class. It goes through those 2 points. Let's look at another one here. So I can look at this and I can tell that my 2 roots are 6 and minus 6. See, if I put a -6 here, -6 plus 6 is 0. 0 times anything is 0. All right. If I put a 6 there, 6 minus 6 is 0. And 0 times, doesn't matter what that is 0. So those are my 2 x-intercepts. So at 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. Those are my 2 x-intercepts. X times x is x squared, so my a is 1. So I know my graph looks like that. Sure, it might be like this, you know, but it goes through those 2 points. It looks roughly like that. That's why they say a possible graph. They're not looking for the exact one. Check out this example. All right, so here's f of x, 6x squared minus x minus 12. Here's the x-intercepts at 3/2 and negative 4/3. So here's our function. I know that my factors here are going to be at x minus 3/2 and an x minus a negative 4/3. And x minus a negative would be plus. All right. But I don't like these fractions in here, right? So what I'm going to redo is I'm going to rewrite this. I'm going to pull out 1/2, right? And then I'd have to rewrite this factor here as a 2x minus 3. Right? The 1/2 times a 2x gives me an x. And the 1/2 times the 3 gives me 3/2. And now this one, I'm going to pull out a 1/3. So I can rewrite that factor as a 3x plus 4. 1/3 times 3x is x. 1/3 times 4 is 4/3. Now what I'm going to do is take these numbers, put them together. 1/2 times 1/3, and now I got this. See, I'd rather have this one fraction out here than have 2 fractions in there. So this is the factorization that I like best for this, right? These are all equal. See the equal signs? They're all equal. They're all the same thing. So they're all correct. But this is the preferable one, because we just don't want to have fractions in our factors if possible. But this is just an example where knowing your x-intercepts, you can write down the factorization exactly. So solving equations using the zero factor property, right? If I factor this equation, then I could set all the factors equal to 0. Let's focus on number 1 for now. Right? If 9x squared minus 16 is 0, I can rewrite this as a 3x squared minus 4 squared. All right? If that's true, since that's the difference of 2 squares, I can rewrite this as a 3x minus 4 and a 3x plus 4, because that's a difference of 2 squares. Now, if I'm solving this equal to 0, if this is 0, it doesn't matter what that is. 0 times anything is 0, right? So to make this equal to 0, either one of these factors has to be 0. So I just busted this equation into 2 smaller equations. Just take each of the factors and set them equal to 0. So this one says that x would have to be 4/3. This one tells me that x would have to be a negative 4/3. So these are the 2 solutions to this equation. And you could check your work by plugging the x in, right? 9 times a positive or a negative 4/3 squared minus 16. See, 4 squared is 16. 3 squared is 9. Positive or negative squared is positive. I got minus 16. 9 over 9. 16 minus 16 is 0. So I check my work, make sure that my solutions are correct. Let's look at number 2 here. Okay, this guy's not in standard form. We got to get everything and set the whole equation equal to 0. That way, when we factor it, we can just set each factor equal to 0. So if we subtract 9 from both sides, I get what? Plus, what's 16 minus 9 today? 8? No. Yeah, no. 7. So, yeah, 8, 9. Hold on. It's one of those days, folks. What is it? 16 minus 9? 16 minus 10 would be 6. So it's 7, right? All right. And this is equal to 0 now. So if I can factor this guy, this happens to be one where you could just eyeball it. Right? Two numbers that multiply to be 7, but add to give us 8. 7 and 1. All right, we didn't have to do the PQ trick or any of that because there is no number in front of the x squared. All right, we just look at it. 7 times 1 is 7. 7x plus x is 8x. So this equation is 0 when either one of these factors is 0. Right? If I put a negative 7 in right here and right here, I would get 0 times negative 6. It wouldn't matter what this one is, as long as one factor or the other is 0, the whole thing is 0. So we set both factors equal to 0. This tells us that x is negative 7. This tells us that x is a negative 1. Those are our two solutions. And we can check our work by plugging them in up here. If I put a negative 1 in for x, negative 1 squared would be a 1. And we get a minus 8 plus 16. That would be 16 minus 8 is 8 plus 1 is 9, right? So negative 1 works. And you can similarly check your minus 7, make sure that it works too. All right. Again, let's get everything set to one side. Set everything equal to 0. Right? We want everything to be nothing. So we got 2x squared. If I subtract or add a 7x to both sides, and then subtract a 2 from both sides, I got that. Now we got it in standard form. Now we can use the property. So now if we want to factor this guy, because we got a number in front of our x here, let's use our AC trick. A times C is 6. So our P times Q needs to be 6. B here is 7. So P plus Q needs to be 7. So two numbers that multiply to give us 6 and add to be 7. That would be a 6 and 1, right? So we're going to rewrite the 7x as 6x plus 1x. Now if we factor out our 2x here, we got x plus 3. And now this x plus 3 here, right? We got x plus 3, right? How did we deal with this last time? We see our x plus 3, right? But how are we going to factor this? We rewrite that x plus 3 is 1 times x plus 3. So now you can see clearly that we have a 2x and a 1, both being multiplied by an x plus 3. All right, so either one of these factors has to be 0 for the whole thing to be 0. So either 2x plus 1 is 0 or x plus 3 is 0. This one tells us that x would have to be a negative 1/2. This one says x can be a negative 3. So these are our two solutions to this equation. All right, it's 10 past 4. Let's take a 5-minute break, y'all. We'll come back at 415. This one has some fractions in it, no big deal. First, let's get this thing in set equal to 0. Now, I don't really want to deal with all these fractions here, right? So what I'm going to do is I'm just going to multiply both sides of this equation by 9. So 9 over 9, I get x squared. 9 over 3 is 3, times 2 is 6. 9 times 1 is 9. 9 times 0 is 0. So now I have something much easier to factor, right? This one I can just eyeball. I need an x and an x, two numbers that multiply to give us 9, that add to give us a negative 6. So either x minus 3 is 0 or x minus 3 is 0. These both tell us that x is 3. So this equation only has one solution, but it has what we call multiplicity 2. It's the same solution twice. Basically, the graph of this guy would look something like this. It would come down and touch the x-axis at x equals 3. That's why it shows up twice, but it's only one solution. Okay. But you can see the trick here. Nobody wants to deal with a bunch of fractions. So get rid of them. Right, this guy's in standard form, but it has all kinds of x's in it, right? Let's see. We can't pull out none of these three numbers. They don't have any shared divisors, but we can pull an x out. If we do that, and let's put the highest power first, we'll have like a 4x squared, right? That times that gives me that. And then we'd have a 20x and then a 25. All right, so we just need to factor this guy now, right? We can use our trick here. A times C is 100. So we need our P times Q to be 100. Our B here is 20. So we need P plus Q to be 20. Two numbers that multiply to give us 100 and add to be 20. 10 and 10, right? They multiply to give us 100 and add to be 20. So let's rewrite. We got to keep our x out here. Can't forget about it. We're going to rewrite the stuff on the inside here as 4x squared plus 10x plus 10x plus 25. And that's all still equal to 0. So I got x. I'm going to use a square bracket here so I don't get things confused inside of here, because now I'm going to have factors inside of factors here. For these two, I'll pull out a 2x. 2x times 2x is 4x squared, and then a 5. Right, 2x times 5 is 10x. Now for these, I'll pull a 5 out. That'll give me a 2x plus 5 again. So notice I got this addition in here, right? That's why I'm using these square brackets, right? Because if I was going to multiply this x through, it would be x times that and x times that, right? But see, we still got our x. Now we got a 2x plus a 5 times 2x plus 5. Forgot my equals 0. So here's our factorization. We have 3 factors now, right? There's an x cubed. That means there's 3 solutions. If I plug in a 0 for x, 0 times anything is 0. So I have either x equals 0 or 2x plus 5 equals 0. And of course, this one shows up twice. But this one being x would have to be a negative 5 halves. So these are our 2 solutions for this equation, but 5 halves has a multiplicity of 2 because it shows up in 2 of the factors. All right. First off, we can get a 2 out of there. All right. We're going to divide both sides by 2. That's still 0. So we're focused on that now, right? I think we could factor that just by looking at it. We need a t and a t. See, 2 numbers that multiply to give us 18 and add to be 9. 6 and 3, right? Gives us our 18. 6t, 3t gives us our 9t. So either t plus 6 is 0 or t plus 3 is 0. So either t is a negative 6 or t is a negative 3. There's our 2 solutions for this equation. All right, let's throw everything to one side. 10x squared minus 5x equals 0. See, I could pull a 5x out. That would give me a 2x minus 1. All right. I can get rid of this 5 here. If I divide both sides by 5, that's still 0. So either x is 0 or 2x minus 1 is 0. 2x minus 1 is going to be 0, then x would have to be a half. So there's our 2 solutions to this equation. All right, more fractions. It's all right, we're going to get rid of them. First, put it in standard form. Let's see, if I multiply both sides of this equation by, say, 10, right, to get rid of that, what do I be looking at? I'd have a 10 over 5, which would be a 2. Then I'd have a 10 over 4, which is 5 halves. The 10 over 10 go away, right? So I got rid of some of the fractions, right? I still got that 2. So I'm going to multiply both sides by 2. That gives me a 4x squared. The 2 over the 2 go away. It gives me a 5x. Then a minus 6. And 0 times 2 is 0. So I'd rather factor this than that. So let's use our trick. A times C. 4 times negative 6 is a negative 24. So we need 2 numbers that multiply to give us a negative 24. B here is 5. So we need our 2 numbers add to give us 5. So what can we do? Let's see. 8 and 3, right? A positive 8 and a negative 3 multiply to give us a negative 24. And an 8 minus 3 give us a 5. So let's rewrite our 5x. as 8x minus 3x. So these two terms, we can pull a 4x out. That would give us an x plus 2. And over here, we can pull out a minus 3. And that gives us an x plus 2, right? A minus 6, minus 3x. So we got a 4x and a negative 3, both being multiplied by an x plus 2. So now we have this thing factored using the zero factor property. Either 4x minus 3 is 0 or an x plus 2 is 0. This one tells us that x would have to be 3/4. This one says x is a negative 2. So there's our two solutions to this equation. Any questions, y'all? Number 9. Ugh. Let's see. I can't see any number we could pull out of all three of those. If we use our trick, a times c, 25 times 8 is 200. So we need a p times a q that give us 200. B here is 45, so I need a p plus a q that give us 45. I'm gonna have to use my calculator for this. Let's see. Let's see, 200 divided by 5. That was easy. So it turns out I divided 200 by 5 and I got 40. So if I did 5 and 40, they multiply to be 200 and they add to give me a 45. So if I rewrite this equation as 25x squared plus 5x plus 40x plus 8, these I could factor out a 5x. That would give me a 5x plus 1. And these I could factor out an 8. And I get a 5x plus 1 again. So I got 5x and an 8, both being multiplied by a 5x plus 1. So either 5x plus 8 is 0 or 5x plus 1 is 0. This one tells me x would have to be a negative 8/5. So it tells me x would have to be a negative 1/5. So those are my two solutions to this equation. All right, let's see. I can pull a 3 out of both of those. All right, from here I can divide both sides by 3. So x squared minus 4, right? That 4 is a 2 squared. So the difference of two squares. So either x minus 2 is 0 or x plus 2 is 0. So x equals 2 or x equals negative 2, plus or minus 2. All right. Or we could have used the square root method, right? X squared minus 4 equals 0. We could have been like, okay, x equals 4, square root both sides, absolute value of x equals 2, so x equals positive negative 2. All right, same trick. No, different trick, same answer. All right, let's get rid of this 1/2. Let's multiply both sides by 2. That would give me an x squared minus 64. 0 times 2 is still 0. So again, you can use the square root method, but they asked us to use the 0 factor property. So instead, we're going to just factor this. An x minus 8 and an x plus 8, right? 64 is 8 squared. So either x minus 8, let's try that again, is 0, or x plus 8 is 0. So either x equals 8 or x is negative 8. All right, which you get even if you did it the other way. If you added 64 to both sides, square rooted both sides, you got the absolute value of x be 8. So x equals positive negative 8. Same answer, two different methods, right? All right. Again, we could use the square root method, but they want us to do it the other way. So let's put this guy in standard form. This is the difference of two squares. So we can factor it. 4t of 4t plus 7 minus 7. So either 4t plus 7 is 0, or 4t minus 7 is 0. So this tells us t is a negative 7/4. So it tells us t is a positive 7/4. Two solutions to this equation. All right, let's move everything to the left side. We'd have a 4x squared, a minus 11x plus 6 equals 0. All right, let's use our ACPQ trick. 4 times 6 is a 24. So we need our P times Q to be a 24. B is negative 11, so we need our P plus Q to be negative 11. Two numbers that multiply to be 24 and add to be negative 11. So we could pick two negative numbers, but 8 and 3, both negative. They multiply to give us a positive 24 and add to give us a negative 11. So looking at this guy, we take this middle term and rewrite it as a negative 8x minus 3x. I put them in that order because the 6 and the 3 go together and the 4 and the 8 go together. So I can pull a 4x out and I got an x minus 2. Then over here I got a minus 3 times an x minus 2 again, right? Negative 3 times a negative 2 is a positive 6. So I got a 4x and a negative 3, both being multiplied by an x minus 2. So either 4x minus 3 is 0 or x minus 2 is 0. This one tells us that x is 3/4. This one tells us that x is 2. And again, we can plug these numbers in for x in the equation and make sure that both sides are equal to check our work. Here's the last example of the section. It's already in standard form. 43 is an ugly number. There's no number we can pull out of here. So we're just gonna have to do it as is. Let's use our trick. Let's see, 15 times 30 would be 450. So we need two numbers that multiply to give us 450. B is 43, so we need our numbers to add to give us a 43. It's going to be tough. See, if I take 450 and divide it by like 20, no, it didn't work out. 450 divided by 30. 30 and 15. You know what? I think this is another typo. I think that's supposed to be a 5. So that we can write P to be 30 and Q to be 15. That way they multiply to be 450 and they add to give us a 45. So let's just work this problem. So if we rewrite this, it's 30x plus 15x. We could pull out a 15x out of there. That would give us x plus 2. And over here, we could pull a 15 out, and it gives us another x plus 2. We got a 15x plus a 15 times an x plus 2. So we could rewrite this, right? We could pull that 15 out. We could have done it in the beginning, right? This is 15 times an x plus 1 times an x plus 2. So we got x plus 1 is 0 or x plus 2 is 0. You don't need to set 15 equal to 0 because 15 is never equal to 0. So x is -1 or x is -2. So that completes this section. I guess not. But wait, there's more. I guess you can't get enough examples. Oops. Okay. Let's see what these guys have for us. All right, let's put it in standard form. 2x squared minus 3x minus 35. All right, we can't pull a number out of any of these, so let's do our trick. 2 times -35 is -70. So that's what we want our P times Q to be. B here is -3. That's what we want our P plus Q to be. Okay, so multiply to be -70, add to give us -3. Let's try -10 and 3. No, 7. All right, they multiply to give us -70 and they add to give us a -3. So let's rewrite -3 as a -10x plus 3x. We could pull a 2x out of those first two terms, like that. We could pull a 3 out of these. Wait, that didn't work. What did I do? Oh. This is supposed to be a 7. So I need to pull a 7 out. 7 times 5 is 35. So we have this shared term. We got a 2x and a 7, both being multiplied by an x minus 5. So either 2x plus 7 is 0 or an x minus 5 is 0. So either x is negative 7 halves or x is 5. Those are two solutions for this equation. Any questions, y'all? Y'all following okay? Y'all still there, right?
Yes.
All right.
Yes, sir.
Okay. I don't see a number we could factor out all three of these, so let's do our trick again. A times C. Oh, geez, what is 6 times 24? 144. That's what we want our P times Q to be. B is 7. That's what they need to add to be. Oh, I don't know how that's going to be possible. Wait, I mean, you got 12 times 12, right? Oh, wait a minute. This is a negative 144. All right. There's a negative 24 there. All right, this is doable then. Let's see. We can't do 12 times a negative 12 because they would have to be 0, right? So let's see. 8 times 18 is 144. But yeah, their difference isn't 7. Let's see. Da, 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 da. 9 and 16. 9 and 16. We need to make the 9 negative. All right, I figured that out just by taking 144 and dividing it by numbers starting at like 1, 2, 3, 4, 5, you know? So these multiply to give us negative 144 and they add to give us 7. So I can rewrite 7t as a negative 9t plus 16t. So let's see. These I can factor out a 3t. It gives me a 2t minus 3. These I could factor out 4, right? No, an 8. Gives me a 2t minus 3 again. So we have 3t plus 8, both times a 2t minus 3. So either 3t plus 8 is 0, or 2t minus 3 is 0. This one tells us that t is a negative 8/3. It tells us t is 3 halves. There are two solutions to this equation. All right. I don't see any number that we can factor out all of these. Not off the top of my head, anyways. This is going to be a tough one. Let's see. A times C. What is 75 times 12? Is 900. And it's negative. All right. Oh, no, wait a minute. Before we do that, I just realized 75 is divisible by 3. And so is 32, I think, right? No. Damn it. Never mind. We do have to go. I thought I could factor a 3 out of all of these, but 32 is not divisible by 3. All right. Our B is a negative 32. So we need a P and Q that multiply to give us a negative 900, but add to give us 32. So let's see, if I think 900 divided by, say, 50. Good guess, right? Because 900 divided by 50 is 18. So negative 50 plus 18 is negative 32. So I got it on my first guess. It's my lucky day, right?
Great job, sir.
So we can rewrite this as negative 50x plus 18x. Is that how I want to write it? Or do I want to switch these? What can I divide out of 18 and 75? What do they have in common? 6 or 3? I can factor 3 out of both of these, right? All right, so for these two, if I pull out a let's see, I'm gonna factor out of these. I mean, I can pull a 2 out, right? A 2x, that would give me a 6x minus 25. And these, I could pull a 3 out, and that would give me a 6x minus 25 again. So we got 2x plus 3 times a 6x minus 25. So either 2x plus 3 is 0, or 6x minus 25 is 0. So it tells me x is a negative 3 halves. So it tells me x is 25 over 6. Which I don't think I can reduce that. So there's our two solutions. All right, at least I can divide everything by 2 here, right? Hell, I could pull an x out as well, right? Everything has an x, so let me pull a 2x out. That would give me a 15x squared minus x minus 2. I can get rid of that 2 there, just divide both sides by 2. So I got this x times this guy. If I want to factor that, we'll do our trick again. A times c is a negative 30. What our p times q needs to be. B is a negative 1. That's what our p plus q needs to be. So two numbers that multiply to be negative 30 and add to be a negative 1 was negative 6 and positive 5. They multiply to give us negative 30 and add to give us negative 1. So let's rewrite this guy over here as x times 15x squared minus 6x plus 5x minus 2. So I'm going to have to use my square brackets here for a second, because if I don't, things won't look right. Let's see, here I can pull out a 3x. Gives me a 5x minus 2. And that didn't work. So I can't factor anything out of these two. So what I need to do is switch these. Let's put the plus 5x and then the minus 6x. Now I can pull a 5x out of here to give us 3x plus 1. And then on these, I can pull out a negative 2 to give me a 3x plus 1 again. So notice these brackets are kind of different, right? We got this minus sign in the middle of all this, but we can get rid of them now because we got 5x and a minus 2, both being multiplied by a 3x plus 1. So we have three terms here. Either x is 0, 5x minus 2 is 0, or 3x plus 1 is 0. This one tells us x has to be 2/5. This one tells us x is a negative 1/3. So there's our three solutions for this third order equation. Why are there so many examples? Alright. Let's put this guy in standard form. We got a 4x squared minus 31x plus 21 equals 0. I don't see any number we can pull out of all three of those, so we'll do our trick here. A times C, this is what, 84? Our B here is a negative 31. Two numbers that multiply to give us 84, but add to give us a negative 31. So we're going to have two, both of them are going to have to be negative. So let's see, 84 divided by like, try 16. No, let's try 84 divided by 4. 4 and 21 multiply to give us 84, but they don't add to be 31. So let's try 6. 6 and 14 multiply to give us 84, but they add to give us 20, right? So 8, 9, 10. Let's see, 42 and 2, but that would give us 44, right? There it is. 84 divided by 3 is 28. So 28 and 3. When we multiply those, we get 84. They add to be a negative 31. So we can rewrite our minus 31x as a minus 28x minus 3x. These we can pull a 3 out of. These we can pull a 4 out of. So we got a 4x times x minus 7, right? 7 times 4 is 28. And over here we have 3 times x minus 7 again, right? Negative 3 times a negative 7 is a positive 21. So we got our 4x and our negative 3, both times x minus 7. So either 4x minus 3 is 0, or an x minus 7 is 0. So either x is 3/4 or x is 7. Those are two solutions. So I'm assuming they have so many examples because they really, really, really want you to learn how to do this. At least we could pull a 10 out of all of these, right? That would give us an 8x. Well, hell, we can also pull an x out of all of them. So let's do that. pull out a 10x. So that would give me an 8x squared minus 6x minus 9. And get rid of this 10 by both sides by 10. So now I'm looking at this guy. And to factor that, let's do our trick. A times C. What's 9 times 8? Can anybody tell me?
72.
Anybody? So 50 something, 57, 56. 9 times 8, 72. So it's a negative 72. That's what our P times Q needs to be. Our B is negative 6, so that's what P plus Q need to add to be. All right, so they're going to multiply to be negative. One has to be positive and one has to be negative. So was it 12 and 6? Yeah. Negative 12, positive 6. They multiply to be negative 72 and add to be a negative 6. So let's rewrite this guy. We got our x. We got our 8x squared. We're going to rewrite this negative 6x as negative 12x plus 6x. So for these two, I pull out a 4x. It gives me a 2x minus 3. These, I can pull a 3 out. That gives me a 2x minus 3 again. I got my x here. 4x plus 3, both being multiplied by 2x minus 3. So I got 3 terms, x, 4x plus 3, or 2x minus 3. So either x is 0, or it's negative 3/4, or it is 3/2. There's our 3 solutions for this third order polynomial equation. All right, it's 5 o'clock. Let's look at exam number 17. So let's see. Did I give you all these problems yet?
No.
Anybody remember?
They look a little familiar, but I don't remember exactly if those are it.
All right. Let's go ahead and do those. So here's your number 1. Number 2. And solve them using the square root method. This one a little bit bigger. All right, class. Have your answers in by midnight. And I'll see y'all on Thursday.
All right. Thanks, sir.